Okay guys, so I wanted to make a video today just explaining how this works with isosceles triangles and circles. So that's your heading for today. So this is isosceles, sorry I misspelled that, isosceles triangles and circles. So we're going to look at when triangles are formed inside of circles and what sort of angle properties they have. Okay, so what I want you to do is I want you to draw, and we've got a bit of note taking to take, so I want you to draw a big circle well, not that big, but covering kind of half of your page left to right. If you want, you can use like a mug to draw around, or a kind of coin, a 10p coin, or anything like that, to, if you care about having a perfect circle, use something like that. Okay. So you don't need to copy down this first bit, okay? But we know already that a diameter is formed when a line is drawn from one edge of a circle through the middle to the other edge. So if I took a line right now and drew it from one edge through the centre to the other edge, we know that as a diameter, okay? And that's fine, we know that already. Okay, but we're not looking at diameters just now. So what we're looking at today is if we had any line joining 2 points on a circumference, it has a special name called a chord. So technically a diameter is a chord, because it's basically, if I drew something like this, okay, that is a line going from one edge to the other edge, which is exactly what a diameter does. It's just a diameter is a special chord that goes right through the middle. But write this down, please. Everything that you're going to see from now on, you need to write down. So any line that joins 2 points on the circumference is called a chord. Okay, so it looks something like that. So if I had 2 points, say I call this one A and I call this one B, then that is a chord that is formed. All right. Now, if points A and B are joined by a chord and then joined to the middle of the circle, then an isosceles triangle is formed. Now let me show you exactly what I mean. So if we mark a wee dot at the middle of our circle, so say it's about here, and if I now join, I've got my chord AB, okay, and if I join each point to the centre of the circle, each of those lines I've just drawn is a radius of this circle. Now I've gone from the edge to the centre. We know that that always forms a radius. So these lines are exactly the same length. So that makes this an isosceles triangle. Now, what does that mean in terms of the angles? Well, it means something very particular about the angles at each corner here. If I call the centre O, we can make this claim that therefore angle OAB, which is this one on the bottom left, is exactly the same as angle OBA, this one on the bottom right. Okay, so that's a rule for angles in triangles and circles, that if you have two radiuses joining with a chord, they form an isosceles triangle, which means that these two angles are the same. And that allows us to find some missing angles. Okay. Right, so we're going to look at a few examples. So I'm going to go through these relatively quickly. If you need to obviously pause the video at any time, you can do so. I do want you to draw out the shapes each time, so draw each circle with each triangle inside it for your notes. So if you need to pause the video and do that, then just make sure and do that. Okay, so we've got a circle here in example 1. We have another chord drawn between A and B, and we have formed an isosceles triangle by connecting A and B to the centre O. Okay, so we know from our basic rules there that this means that angle OAB is the same as angle OBA. Okay, and we're trying to find angle X. So what I can say is that I kind of get two choices here. Either you can draw it and just fill it in your picture, and that's acceptable, or you can write it at the side. Now I've not got very much space there, so I'm just going to write it at the side. So I know that angle OAB is 30 degrees. Now because it's an isosceles triangle, I can therefore state that angle OBA is also 30 degrees. So what that means is now I can use my simple angle in a triangle rule, that they add up to 180, to find my missing angle X. So I can say that X is 180 minus 30 minus 30, because the two of these are now 30 degrees, and I can write it in there. So that means, quite simply, it's 180 minus 60, so that's 120 degrees for angle X. Okay, let's look at the next one. So again, similar, this time I've got another circle, a chord drawn somewhere else, and two radiuses connecting the centre O. Now this time I'm not given the angle in the corner, I'm given the angle at the centre, and it's at angle AOB is 106 degrees, and I'm looking to find angle OBA. So, slightly different. We know that angles in the corner for isosceles triangles are the same, which means that the two, remember we did some of these before when it was just a normal triangle, the two of these angles are both going to add up to the difference between 180 and 106. So first of all, find the difference between 180 and 106, and then if you divide that answer by 2, that's you got that angle OBA. Okay, so first of all, 180 take away 106 is going to be 74 degrees. 74 degrees. Now angle OBA, and please get in the habit of actually writing down what angle you're looking for, don't just write random numbers down. Angle OBA is equal to therefore 74 degrees divided by 2, because each of these are identical, so we split it in 2, so that means angle OBA is therefore 37 degrees. Okay, and the last example I'm going to show you, again, I want you to draw your own circle, and just slightly different here. I have a chord in red drawn here, and I have two radiuses extended to the centre, and I have just a diameter drawn there as well. Okay, and what the information I'm given this time is that the angle at O between the diameter and the one of the radius is 85 degrees. It's probably easier actually if we mark on some letters here. So why don't we call this, let's call this M, N, and P. Okay, so what we can say is state that angle NOP is 85 degrees. We know that from the picture, that's this one here. So what I need to do first of all is using a supplementary angle rule, 180 degrees, this is a straight line, my diameter, I can get angle MOP, angle MOP. So angle MOP is just 180 minus 85 degrees. So angle MOP is therefore 95 degrees. Okay, now it's a similar question to what I had in the previous one. I need to find the difference between 95 and 180 to get what each of these, or what these are in total at MP, and then divide by 2. So 180 minus 95, that's 85 degrees. Okay, so angle C, which you can either call it C or you can call it kind of OPM, is more mathematical way to call it, is going to be 85 degrees divided by 2, because 85 was the total of these two angles, remember, so they're both the same, so divided by 2, so that's going to be 42.5 degrees. Okay, so you should be able to use these examples now to successfully work your way through the exercise on isosceles triangles in a circle.